thank you for the pleasure of presenting to you the Schneider Electric and also reviewing what does liquid cooling mean for the new era. Liquid cooling is a necessity as we go into the AI era. It is a critical enabler. Without it, we cannot support the accelerated compute that's required for the training and inference of data center of AI and the training that's associated with it. It is an evolution that we're seeing. It is not. It's an industrial revolution that requires us to be prepared to have the right product, the right service, and also the scale to deploy it consistently. We want to talk about why are we doing liquid cooling. It's really because the GPU requires it. No longer are chips or the GPUs can be cooled with air alone. It has to be direct-to-chip cooling. That is the technology that's been adopted, and it's also the technology that will lead us into the next generation of chips, all the way up to the 1 megawatt and beyond per rack. If you see, as we look at the evolution today, it's grown 4x, and we see in the future it will grow even more. That means there's increased demand on the infrastructure and precision of how we cool it. Just to put it in perspective, a 1 megawatt rack is about 200 ovens or stove in your house in a single rack. That's the heat that we're trying to remove at every single rack when it gets to 1 megawatt. Even at 130, 140 kW today, that is still a lot of heat into a small area. These are the evolution that we've seen in cooling for data centers. When there were supercomputers or cray computers in the past, they were liquid cooled. But modern computers have started out using room cooling air-based with raised floor, and we've evolved to containment in the early 2000s to really satisfy the densification on just cloud computing and CPU. But beyond that, as we go past that, containment no longer is able to keep up with it. Air cooling really maxes out at about 70 kW a rack just because of the physics and the amount of air that needs to move through a rack to cool that density. Beyond that, we really have to manage it with liquid cooling. Schneider is the leading liquid cooling company for the industry. We have the full portfolio. With the addition of Motivair, we have really acquired decades of cooling technology that's been deployed at scale. We'll talk about multi-megawatt deployments of up to 400 kW per rack with liquid cooling, and that was done 10 years ago. We're taking that application and scaling it to meet the requirements of today. That means we have already cooled densities above 400 kW. Now, with AI, we have to scale that so that we make it available across the board to everyone. And it's at 130 kW today. We'll quickly go to 250, 400, 600, and all the way up to 1 megawatt and beyond. But as we talk about liquid cooling, we cannot forget about air side. Air side is still crucial to remove the rest of the heat. Even today, we see that at 130 kW a rack, between 10 to 40 kW, or roughly about 20% of the heat still needs to be managed by air. As we progress into higher densities, the efficiency of the liquid cooling will increase, but the amount of heat per rack will probably still stay the same. At a 1 megawatt rack, you will still likely see 40 kW of residual heat, which means you still have to cool that. And as you know, liquid air cooling at 40 kW a rack or 30 kW rack is still high performance cooling. So you need to have the right strategies to cool that. You need at least containment if you're going to use room cooling, or you have to use close coupled cooling to really manage that heat efficiently to make sure that even with liquid cooling, the rest of the server and of the pod still work properly and efficiently. I think many of you guys have seen a slide like this, but you see the density is quickly ramping up. 1 megawatt rack, we see prototypes today, but on the roadmap, we're only a few years away from the deployment. But don't let that scare you. 1 megawatt rack will still be only the top tier providers. The current technologies will still be in use for the foreseeable future. As with any new technologies, not everything will move directly into 1 megawatt rack. The availability and the functionality is only for the highest end computing. You will still see the current portfolio still remain in effect, mainly because there are existing data centers and existing access to power that cannot manage 1 megawatt of rack. So the deployment will be a mix going forward, which means the full portfolio will sustain even when new and more dense servers are deployed. What does it mean? What changes are made when we introduce liquid cooling into the data center? How does it affect the IT manager? How does it affect the operator? How does it affect the service providers and also the designers? The reality is there are concerns about having coolant or water close to the rack. But when liquid cooling is going into your server, it's going to be a fact of life. You're going to have to manage it. You have to get comfortable with it. That means your entire operation has to evolve. Just like the cooling innovation and equipment have to evolve, your operation and installation and maintainability of it have to evolve. People inside the white space generally do not deal with the gray space equipment like piping, pumps. We're moving the white space closer to the gray space. When you're talking about megawatt power capacity for per rack, the amount of power going in, the number of cables to get the power into the rack is no longer low voltage. It's no longer safe for technicians. You have to reduce the current and the bracing of the equipment in order for it to be safely operated, which means additional training has to be done. Also, your installers and the equipment have to evolve to make that safe. That's the challenge is, cooling, the technology that we have today, we can support up to 1 megawatt and beyond per rack. The cold plates are designed and able to manage that. The challenge is also the power. And how do you make sure you get the power and the cooling out into a small footprint? That is a challenge. And we will see that architecture may change. The server will evolve. Today, liquid cooling isn't an expansion of infrastructure. It is the extension of the server. In the past, heat sinks and air, the heat sink was part of the server. With liquid cooling, we move that outside, and it becomes external to the server, but it's still critical for the server to operate. As you go higher in power density, you will see that the power supplies that are currently inside the servers will likely move out in order to make room for more servers to get more dense, which means you will have additional sidecar for even getting the power in. With that said, there are existing systems, existing investment from our customers. Everyone is on a different journey to liquid cooling, and a lot of our customers and a lot of the industry, at any given time, any given site, you're probably on a modernization, retrofit, or a new build. And all of the above may apply, which means we need to have strategies for enabling liquid cooling even in existing data centers, but also retrofits. That brings a whole new risk, which is as you expand, how do you commission the liquid cooling? How do you test it? This is where the size of the loop matters, and the effect or the blast radius of how many servers are connected on a single TCS loop really comes into play. How much risk, what's your risk profile? It really determines where and when we manage that. And if you want to scale, to deploy at scale, you really have to think about what's available in the supply chain. A lot of the piping and piping accessories that meet the criteria for wetted material on the TCS loop really have limitations on the size. Readily available, you're talking 300 millimeters or less, 150 millimeters or less are readily available. Beyond that, the valves, the accessories, all of that gets harder and harder to get, and it's not readily available. So when you size the TCS loop or SFN, you really have to look at what is the supply chain that can support that deployment at scale. You're talking gigawatts, you're talking hundreds and thousands of components that have to be deployed. You don't want to have a supply chain or lock into a supply chain where it's made to order. You want to really look at what is stocked and what can we achieve readily. That also means training of your teams. The teams that are at the rack are no longer only servicing or managing the IT equipment. They also have to be at least trained and comfortable with all of the accessories and power and cooling that's part of it, and understand how to detect when there's a problem, and more importantly, what to do to contain it, and then return to normal. So training is a huge part. It has to be part of the deployment strategy. If you don't think about it up front, when you deploy and turn it over, this is where the first year of deployment is where the risk comes. So you need to be prepared and have the right people trained and educated around how to manage and recover or to identify potential risks to prevent any issues. Now we'll talk about there's a lot of news out there around gigawatt sites. We heard it today. There's lots of investments out there. But in a lot of regions of the world, there are data centers that have to be retrofitted. Access to power may not be a problem here, but globally, that's a consideration. You really have to think about what can you do to maximize it, and also how do you make sure that your overhead power is minimized, which means if you have a 50 megawatt power connection, how much of it actually goes into the compute, and how much is it going to the power transformation and also the cooling of it. I think this is where, as you lower the overhead, this additional power, additional servers that you can serve, which maximizes it. And this is where software and optimization of the entire loop is necessary. We've done studies and looked at when you optimize it end to end, and not just by component, we're able to save up to 15% or even 20% of annual power consumption. But more importantly, reduce the peak power, because that's where the power reservation is. That's where you will guarantee that you have the suitable and comfortable power for your servers. I'll talk a little bit about the portfolio and what it means to have an end-to-end solution. And our portfolio is set up really to manage and support customers no matter where their journey is in liquid cooling. We have a portfolio that support bridging capabilities, also modernization, but also complete greenfield, new builds, where we really design purpose-built data centers for liquid cooling. They have different challenges. They also have different opportunities. With our portfolio, we offer the rack-mounted manifolds, which allows coolant to enter the servers. We also have heat dissipation unit. These are liquid-to-air solutions that allow any existing air-cooled data center to deploy small-scale nodes, which means each of the floor-mounted HDU is up to 144 kW of liquid cooling. It rejects the heat into the white space, and then from there, it's taken back by the room cooling that may already exist in your data center. There's no plumbing required. It's just hoses to connect between the server racks, and it sits in the row. These are bridging opportunities where we need quick deployment in anticipation of a longer build or renovations. This could be the first phase to allow deployment of liquid cooling very quickly for your enterprise or for your customers. Also, chilled doors. This is up to 77 kW per rack. it's able to cool 100% air-cooled H100s, but beyond that, these units can also cool 40, 50 kW per rack, which is ideal when you couple it with a high-density servers today. At 130 kW, and you add a rear door, now you're guaranteed to have the air side and the liquid cooling all managed by the same loop, and also the same vendor to make sure that they interface correctly. There are rack-mounted CDUs and floor-mounted CDUs. Our rack-mounted CDUs go up to 210 kW in a 4U format. That's the highest in the industry, and beyond that, we see that this is going to beyond 210 kW. We don't see that we would need to be higher density, because beyond that, you need the rack space for the server. So likely, it will transition to floor-mount CDUs, where we have solutions up to 2.3 megawatts, and we're developing additional units to have higher format. But today, this is our solution, and we're continuing to look at different opportunities to expand on that. Of course, we talked about air cooling. We have to be able to support it. We have Indra, that's our traditional line. We also have the perimeter cooling and also fan walls. This is where we're looking at developing solutions where we're leveraging the existing layout to allow for retrofit of liquid cool into existing air cooled data centers. We're developing products that can replace a fan wall or a perimeter cooling units to replace CDUs. Again, if this data center is designed for 10 megawatts, you still have 3 megawatts of air cooling. The rest will be liquid cooling. So you still need 30% of what's there, but the room that it frees up allows you to do the retrofit. And of course, at the end, the biggest power consumption in a cooling system is really the heat rejection or the refrigeration cycle. There are instances where we can use free cooling, but in certain environments like Mumbai, it's very difficult to achieve that without leveraging adiabatic or water usage to accomplish it. And this is where we offer a full range. We focus on air-cooled because access to water is not available everywhere. We've seen in some instances access to water can take 7-10 years to get, which means you have to leverage air-cooled in the meantime. Again, depending on the project and location, the availability of water is different, but for sure, if we can leverage and have high efficiency air side heat rejection, it can be applied across the globe consistently and with standard deployments. We have full range from a screw compressor to maglev oilless airing compressors to manage both the peak power consumption but also the noise level if you're located in an urban area. So with a couple minutes I have left, I really want to talk about the experience that Schneider have with liquid cooling. With the acquisition of Motive Air, we did gain decades of deployed and in the field capacity. We have over 4 gigawatts of liquid cooling deployed globally. And that's some of the highest deployment that is out there. And some of these systems have been running 8 to 10 years. So the experience and longevity of that is where we bring the expertise. Again, Motive Air, the brand for liquid cooling that we have, cools 3 of the fastest supercomputers in the world. El Capitan, Frontier, and one other. But they were deployed 6 years ago, 400 kW rack. They're still the fastest in the world today, which means the liquid cooling was able to sustain that so that you keep the servers operating at peak efficiency. This translates into AI operation. The goal here is converting every watt into tokens as fast as you can and reliable as you can without waste. Because any degradation on the performance of the cooling directly affects the performance of the GPU. If we are not maximizing the performance of the GPUs, we are wasting a lot of energy and a lot of investment in getting that server into production. With that, we also have software and service. Schneider has a global presence of service all across the world, and also we have the end-to-end software to really optimize it. This is where if you look at only hardware, you could miss out on opportunities for energy savings, but most importantly, peak shaving is where really we want to manage that and provide solutions that are off the shelf. We have reference designs that have that, and we would love to share it with you and discuss how does that apply with your data center and where you are with your journey. So thank you, and we'll be here in the booth. If you have any questions, please reach out to me.